Hi everyone. Today I'd like to present another one of my transport conference papers. This paper takes us back to 2013 and the 36th Australasian Transport Research Forum. And this paper is titled Program Evaluation and Applied Case Study. At the time I couldn't use the actual name of the applied case study, but that was, like I said, there was a lot of hush-hush things going on around that. But that is actually the Bruce Highway Action Plan. So a lot of the things I'm going to be talking about here, a lot of the projects, I won't actually be mentioning names, though I think I could probably insert a few names here and there. But the interesting thing was at the time, a lot of information wasn't allowed to be released regarding this program. And this program is actually a massive program. We're talking at about altogether over $16 billion. Some of this is still running, and I think they've changed it now to the Bruce Highway Upgrade Program, I think it is, and it's a reduced version of that, but I still think we're looking at least $8 billion. And a lot of that stuff still hasn't been funded, and a lot, of course, has not been built. But today's paper is going to be focusing on the methodology that was applied to evaluating these projects as part of the program, and what went into it, and all the various projects that are part of this program. So I hope you enjoy. I would first like to take you back to the paper that I authored the previous year to this, and that was in 2012, and that was for the 25th ARB conference. And I actually presented this video in the playlist, the previous video, and this video was actually all about the methodology and the approaches that were used to actually evaluate a program. And I got a few examples in that video, some are smaller programs, and this is actually perfect for the program that was actually to come, which is a Bruce Highway Action Plan. So the methodologies that were developed have actually been applied to the Bruce Highway Action Plan. And I'm going to explain how that's been done and how we've worked that into the various projects as part of this program. So what are the first steps we need to take? First off, you need to develop a model. And this is actually quite critical, that you have a model that can be applied to all of the projects within the program. And then you can combine the projects together to actually form your program outcome. And considering the extent of the Bruce Highway Action Plan and how big it was at the time and all the types of projects in there, it had to be very flexible. There were three key types of projects within the Bruce Highway Action Plan, and they were capacity projects, mostly large ones relating to potentially bypasses, duplications of highways, deviations, that sort of stuff. There were also safety projects. They were generally a little bit smaller, looking at intersections, looking at sections of road with poor alignment, and roads that were not sufficiently wide and didn't have sufficient shoulders. And there were also the flooding immunity projects. Those ones were actually, some of them were fairly high capital costs. You're looking at some very large floodplains that required immunity. What else do we need? So we needed to apply the model to this proposed program, which was the Bruce Highway Action Plan. And we had to come up with the most suitable approach. So in the previous paper, we looked at the simultaneous approach and the sequential approach. So a simultaneous approach is evaluating all the projects together. So you have a project case where you include all the projects, and you have a base case which includes none of the projects. Whereas a sequential approach requires a ranking of projects, and you evaluate each one at a time. So you start with the first one, and then you just go with the second one, which will then assume the first one's going to be built, and you go with the third one, which would assume the second one's going to be built, and you continue on until your budget runs out. So you had to decide which of those approaches was going to be more appropriate to apply to this program. Also, we have to bear in mind as well the limitations of these in terms of scope and data, and considering that we had a very tight time frame for this program. We had about 3 or 4 months, and we were looking at, I think it was about 60 to 80 projects. It was a lot of projects. It needed to be a very rapid analysis, and the model also had to cater for that rapidness as well. So it had to be a model that's able to deal with the rapid analysis and a methodology that could cope with it as well. So in many cases we had to fill in the gaps where the data was not available, and we'd need to make assumptions. And it's important to keep those assumptions fairly consistent across all the projects within the program. So let's take a quick look at the model that I developed. I call this model CARP, which is a concise analysis of road programs model. It can also be applied to projects. In many cases, it's a bit of a combination of the two, because the model is actually split into two parts. The first part is dealing with projects, and the second part is actually combining the projects within a program. Bear in mind, we need to recognize the interrelatedness as well between the projects, so that feeds into each of the various pages, I think it was at the time of this model. So what's different about CARP from maybe some of the other models that we got? Well, Transport Main Roads had an existing model called CBA 6, Cost Benefit Analysis 6, and up to 6.1. And that required quite a lot of inputs, sorry. And whereas CARP reduced those by quite a small number. Like, for example, we're only looking at heavy vehicles and cars, whereas CBA 6 looked at 8 vehicle types. So you rolled a little bit of averaging here. We didn't need to have so much detail as well around maintenance and roughness profiles. We used average roughness across the life of the project. And some of these things made the analysis a lot easier to do because a lot of this other stuff was very data intensive. And we didn't really have the time or the budget to actually acquire all of that data or even do the analysis for all of those. And we've got it within one model, so we keep that consistency. That is quite good. And the model has been tested as well to be within, I think it was in 10 to 20% of what you get with the detailed analysis. So if something was, way out, it's getting a very high BCR, for example, benefit cost ratio, maybe 3.5. So with this model with CARP, you should be getting somewhere between 3 and 4. Whereas if the project was getting very low benefit cost ratio, maybe of a 0.4, let's say, the results are only going to give you between like a 0.3 and a 0.5. So it will give you a very good idea of the economic viability, even though you don't get that pinpoint accuracy. But and sometimes it's very obvious. Some parts of the Bruce Highway doesn't have the vehicle numbers to actually produce a high enough benefits to cover the costs. Some of the areas like the flooding, the closures weren't long enough, and those sort of things could be picked up very quickly using this model, and it would give us a good idea. Whereas if we use the detail model, this program probably will run for several years instead of just a few months. And then once that's been done, we can revisit the projects in a little bit more detail later on and eliminated some of the ones that weren't going to perform particularly well or shouldn't be considered as priorities. So the results also differ a little bit as well. It's simplified in a sense that you're just taking the main groups, like we don't have the breakdown of vehicles like I mentioned before, but we still have the discounting. We've got 4, 7, and 10%. And also within the, you don't have the picture here, but the program part of this is actually got further sensitivity testing as well. And sensitivity testing is actually quite critical when you're looking at a program where you've got deficiencies in data, should we say. So that was an important part of developing this model as well, as having those sensitivity tests incorporated within the model. So let's now have a closer look at the outputs from the model. And this is in terms of a program. So what we're getting out of it is actually quite similar to some of the more detailed economic models. So we'd have benefits, for example. You get travel time cost savings, you get vehicle operating cost savings. We've got safety benefits. We've got benefits to generated traffic. We've got flood immunity benefits. And we have the various externality savings as well. We've also got the costs too. So we include the maintenance costs. And the maintenance is not as much detail as I may have mentioned earlier, but it's more of an average maintenance cost across the life of the project, as well as the capital costs as well. And that is also doesn't go into the extent of the detail of a more detailed model, but again, it's more averaged over the first few years of construction. And on top of that, we've got our sensitivity testing. And considering that there was quite a bit of uncertainty around the inputs, and there was quite a few assumptions thrown in, we've actually kept it fairly broad. So we assumed that the results can actually vary by about 50% either side in regards to capital and also in regards to the benefit side of it. So it gives us a range. But even though you've got a range, it gives us some certainty about where the projects are going to land. So for example, if you've got a maximum for a project, maybe it's only 0.8, then it's not going to be economically viable. Or if you have another project where it's got a minimum maybe of, let's say, 2.1, then that's almost definitely going to be economically viable. So it still has usefulness, even though we're not getting pinpoint results. I will now talk briefly about the methodology applied to the CARP model and ultimately applied to the program evaluation of the Bruce Highway Action Plan. So we've drawn on a number of guidelines, a number of material. So first off, we'd be taking from the Transport and Main Roads Cost Benefit Analysis Guide. So most of those formulas and algorithms that's gone within CARP actually comes out of that manual. And that manual came out in about 2011. So that was designed for CBA 6, but some of those formulas have been simplified to actually go into CARP, but it still remains fairly consistent with that. Also, it's been aligned as well with the Austroads guidelines, and a lot of that actually fed into the cost-benefit analysis manual anyway. So we're looking at those algorithms as well being incorporated. And also as well the National Transport Guidelines for System Management. I think that is now, they've been called that ATAP, so that's been recently updated. But those methodologies and how, for example, your benefit cost ratio is calculated, where should you put your operating costs and things like that, has been held fairly consistent to those guidelines. So the model has been aligned with that, in a sense, making the analysis of these projects within this program consistent with the analysis of projects elsewhere that have been analysis using other models that are also following these guidelines. So you wouldn't expect the results to deviate that much, given that we're following this same methodology. Considering the Bruce Highway Action Plan was pretty much within its infancy, there was not an awful lot of information about and very little analysis on most of the projects that we're actually looking at. So it would have been a little bit difficult to have adopted the sequential approach that I was talking about, as there had been no prior analysis or even rankings to actually be able to do that sequential approach. So the most appropriate approach for this was the simultaneous approach. So we're looking at, in the sense that if none of the projects were built within the base case and all of them got built in the project case, and then we would compare the projects with each other using the benefit cost ratio, determine how these projects should be ranked and how they should be put into the Bruce Highway. Well, in terms of the advice we were providing to the Bruce Highway Action Plan, though a lot of that, it's quite interesting because I think a lot of that has changed since then, but I think this was a good run anyway. And in terms of the advice we provide using this simultaneous approach, I think it was of quite some value. And it will be good to see going forward exactly where some of these projects ended up in regards to the more detailed analysis. But I think as a program perspective, the simultaneous approach gave a feel for the entire program, if everything went forward. And we had some fairly good comparisons because we had quite a lot of consistency that can't normally be done, especially if they're all done by different consultancies that are coming in and they all vary a little bit. So you'd never have that consistency as what we had when we did it within the program itself. So the Bruce Highway Action Plan consisted mostly of projects that were reasonably determined at that point, though there were a few projects that were still at the option stage. So that made it quite interesting as well. So there was still some options analysis going on within that. And CARP was, well, the second part of CARP, the program model, actually you can put all your options in there and can make comparisons. And those comparisons were done using the incremental benefit cost ratio. And that was used to determine the optimal option to actually proceed and compare with the other options within the program itself. And for that, we used the benefit cost ratio. So we're actually comparing the projects to determine a ranking using that. I also like to mention here that we looked at the net benefit investment ratio. And that's something that I'm quite fond of because that's focusing on your returns for capital expense. That is your net benefits, taking out the cost side of it as well, and just focusing on that initial expenditure rather than comparing your benefits and comparing your costs over the life of the project. Because your investment decision is being made now with the money that is currently available. So I always thought that that was a very useful tool. Even though that is not used by Transport and Main Roads, we still recorded the results using the net benefit investment ratio alongside the benefit cost ratio. Most of the time they don't differ too much, but it's quite important to actually look at that if you're dealing with maintenance projects that have got very, very high maintenance. Because your benefit cost ratio sometimes can actually give you a negative number, which is quite strange, but that's when your maintenance savings actually exceeds the capital costs, and that gives you an illogical number, whereas the net benefit investment ratio doesn't provide you with that problem. So both of those were considered and both of those were incorporated into the program to make comparisons, and we also provided some advice based on those two ratios as well. For the benefit of those of you that are not particularly familiar with Australia or for Queensland for that matter, I'll just go into a little bit of the background behind the Bruce Highway Action Plan and what it was all about. So you have the Bruce Highway, which is actually the main road between Cairns and Brisbane. So you have Cairns up in the north, you've got Brisbane down in the south, and this road travels along the coast. And this is the main route going north-south. So actually it's quite critical for people travelling up and down Queensland, and it's a very important freight route as well. As you can see from this other map here, which maybe you can't, it's actually very small, it's not very, there's a whole load of projects that are being proposed along there for various problems in relation to capacity, flooding, and etc., what I'm going to go into later. And these needed to be fixed, considering that this is actually such an important corridor within Queensland. So yeah, this is just for a bit of context. This wasn't actually in the presentation itself, but hopefully this will help you understand a little bit more about what I mean when I start talking about some of the projects later on. So what projects were looked at and considered as part of the Bruce Highway Action Plan? So I may have mentioned earlier that we looked at flood immunity projects, we also looked at capacity projects, and we looked at safety projects. And they all varied a little bit in terms of their complexity, and the CART model was designed to handle most of those. Though some of the intersections that fall under the safety in most cases and with capacity were quite difficult because you require additional outputs. And most of the time you need additional inputs from certain tools such as, I think it's either AIMSUM or SIDRA. And that actually comes into the model. Most of the time that wasn't available. So most of those were kept purely as a safety analysis without considering the impact on traffic. So let's take a look at the capacity projects. So there were several capacity projects along the Bruce Highway, and most of these were the very high capital projects. So looking at a number of bypasses, for example, town bypasses, bypassing towns, I think it was up Rockhampton, Townsville and places like that, and they were very capital intensive because you're building brand new roads to divert traffic around cities. There are also some fairly big intersection projects a little bit further south, somewhere fairly close to Sunshine Coast, and those as well were fairly capital intensive because there's a lot of traffic around there. And some of them were going to overpasses from roundabouts, some of them were expanding the roundabouts and things like that. So there were some very big ones, and these were the most high capital projects out of all of them, more so than the flood or the safety projects. We also had several flood immunity projects. They're also fairly capital intensive, some more than others, and that's always quite interesting in terms of the extent of the flooding and also in terms of the size of the floodplain and also how these projects relate to each other. And a program is particularly good for flood immunity projects. As often is the case that you'll have a section of road that floods maybe in 4 or 5 places, and they may be only separated by maybe 20-30 kilometers. You can't just fix up one part of the road because you still have the road closures as we go along. So how do you work at it in terms of a program? So you could have as a program, it's quite interesting because you may have diversion routes for some of these flooded areas and some of them you don't. So it comes down to, again, what I mentioned in the previous video, is the most benefits for the costs that you actually have. So you'd often focus on the worst closures, not necessarily the ones that cost the least, because you want to reduce those closure times to keep the roads open as long as possible. Also got to bear in mind as well, there's also diversion routes. So you may be able to fix up part of the Bruce Highway that allows access to a diversion route, and potentially you could have quite a lot of benefits out of that as well. You also have some projects by themselves will mean nothing. You may spend, say, 30-40 million on a project to reduce closure times down from 12 days, let's say 1 day. But if either side of the road is closed and there's no diversion routes for maybe 13-14 days, then really those reductions in flooding of that area has very little impact. In a sense, you're probably looking at only maintenance cost savings by improving the flood immunity of those sections. So it's very important to use a program to understand the relationships between various parts of the highway in terms of what closes and what doesn't, depending on the flood. And also timing of flood as well. They don't always flood at the same time, so that's something that needs to be factored in as well, and also included in the analysis. For example, if they all flood 10 days a year, but at all different times, then maybe you can fix up one of them. But if they all flood at the same time, then you really need to fix the whole lot up in order to have that whole stretch open. So there's a lot to factor in, and it can be quite data intensive. So a lot of assumptions were thrown in there in regards to the relationships between those projects. So let's now have a look at our safety projects. So many of those were overtaking lane projects and road widening projects. They had some benefits in terms of increased capacity, but quite a focus was actually on safety. Like take, for example, overtaking lanes. quite a large part of the Bruce Highway actually is just 2 lanes. So that means overtaking has to occur on opposing lanes. So you actually got to drive into oncoming traffic in order to overtake. And that's actually quite dangerous. But by having the overtaking lanes in there, it provides safe passing opportunities along those 1 to 2 kilometre sections of road, as well as the benefits of safety prior to the overtaking lane, where vehicles would wait to overtake at the overtaking lane, and also that section, that downstream area after the overtaking lane, where vehicles potentially should have quite a clear run once getting past the slower vehicles. And that was looked at actually in terms of links. So we actually had all the links between Brisbane and Cairns. So we didn't actually look at individual overtaking lanes on this one, but we looked at it in terms of a certain number of overtaking lanes per link, and that was based on the traffic volumes. So if you had a large, higher traffic volumes, you'd actually have more overtaking lanes and be spaced closer together. You have lower traffic volumes that be spaced further apart. So spacing them further apart means you can actually get the benefits of the upstream and downstream areas, whereas those closer together you can't quite get those. But it's more important that you get those overtaking opportunities more frequently, because you're more likely, or vehicles are more likely to encounter slower vehicles. So to get those opportunities to overtake quite improves safety quite a bit. So now we're going to take a look at road widening projects. In fact, they weren't even looked at in terms of projects, but looked at in terms of sections of road which did not meet up to the current safety standards. So that is, either they didn't have median strips, or the median strips are too small, or the shoulders were too narrow. So all of those are fairly important to improve safety. Shoulders in particular are very important. So vehicles that are breaking down have actually got somewhere to pull over and to actually get out of the way of traffic. So that is actually quite important. But we couldn't look at them as individual projects because we didn't actually have enough data around capital costs for each individual project. So we looked at it as one lump sum capital cost, and we looked at the benefits of the whole stretch of the Bruce Highway. And again, taking averages for the traffic volumes along those various stretches. So we actually calculated the benefits as a whole and then divided it by the overall proposed cost for those widening projects. So we actually get an aggregate result for the whole thing. So again, we can't compare individual projects using a benefit cost ratio. We can actually calculate the benefits for the whole, basically the whole stretch of the Bruce Highway for those types of projects and what they're likely to get. And you can break it down later on. And I think overall the benefits I think were higher than the costs. As part of the Bruce Highway Action Plan as well, there were some projects that weren't quite determined yet, so we're still at options stage. So we still had to figure out the best option, and some of them were in combinations. And the one we got here is the Burdekin River Bridge, and that was interesting in itself because we had a bridge that had restrictions on it because of the design of the bridge. Certain vehicles couldn't cross it because they were too big, and at the same time as well, there was also flooding occurring as well. So an upgrade to the bridge would actually, you get improvements from allowing heavier vehicles, larger vehicles, and you also have improvements of the flood, reduced closures as these vehicles could actually cross the bridge and not be obstructed by the flood. But this was interesting because there was a few projects in there, for a few options that looked at just upgrading the road in terms of improving flood immunity, and whereas there are bigger ones that actually created a whole diversion, so actually diverting traffic or creating a deviation to actually bypass this bridge altogether, so to allow complete flood immunity and also higher speeds because you're avoiding the towns along that section of road to actually go through a little bit faster. So it was about 8 or 9 combinations, and the benefit cost ratios we looked at for those, and of course the incremental cost benefit cost ratios we used to compare the two. Also the net present values were also calculated, and many academics, I think, actually advise the use of net present value as a comparison between options. So we actually had that in there as well. I think we also had the incremental net benefit investment ratio as well. So you had a few of those results in there. So let's now take a look at the results of the Bruce Highway Action Plan program evaluation. So let's start with flooding. So with flooding, we got a net present value of a negative $160 million. That's a very large negative number. And we've got a benefit cost ratio of 0.89. So that is a combination of all of your flood immunity projects in there together. So that's including the ones with very high benefits and some of the ones with very low benefits. And so the reason why some of these scored so badly is the fact that capital cost was so high and the closure times are very low. You take it for example, I think it was Horton flood immunity project. That was, I think, it was almost $500 million, but the closure times are only about, I think, about a day a year. Sorry, so the closure times are fairly short, and it's very expensive to fix that up because it's a floodplain. I think it's about 16, 17 kilometers. So all of that would have to be raised just to reduce closure times for about a year. So those sort of projects pulled it down, and overall not a particularly good idea given the returns you actually get back for the costs that go in. Capacity projects, there was a mixture there of good and bad. Overall, we've got a BCR of just above 1 and a very high net present value, even though the BCR is fairly low. Again, bear in mind, we're talking billions of dollars here. So 747 million is very high, but in comparison to the cost, it's reasonably low still. The overtaking lanes, overall, again, there's just over 1.1, the BCR, and net present value of about 64 million. So that looks a little bit more reasonable. A lot less money goes into overtaking lanes, only about 5 or 6 million per overtaking lane. It's quite a little bit less capital intensive. Road widening, even less on that one. Net present value of about 41 to 42 million and a benefit cost ratio of 1.12. And the overall program, I think that's it if we include all of the projects, gives you quite a low benefit cost ratio of only 1.1 and your net present value of about 690 million. Now that sounds fairly high, but you've got to bear in mind that this is in comparison to costs of billions and billions of dollars. My paper actually goes into a lot more detail in regards to the results of individual projects and how they compare. And you'll find that a large majority of the projects actually get benefit cost ratios below 1. So it's some of them that are scoring very, very high are pulling the whole program up. But in retrospect, though, you'd go back and you'd think that you'd actually take out some of these very poorly performing projects from the program simply because it's pulling down. It's not a very good use of the taxpayers' money, considering the benefits you're getting. It's more directed at improving freight times, so you can see industry is actually benefiting more than the actual majority of the Queensland taxpayers for a lot of those. So let's now take a look at the limitations of the program. So the first limitation is the short time frames, as I mentioned earlier, and that was a huge limitation. We had about 3 or 4 months to look at about 70 to 80 projects. Normally, working fairly efficiently, each project is going to take around 3 weeks. So you can imagine you add all that up, you're going to be talking about a year's worth of work at least, probably even longer than that. And that's what made it very difficult. Also as well, the scopes of many of the projects were not finalized. So again, that's the quality of the data, quality information that's coming through. So a lot of them were very broad estimates about what was actually going to happen. And that also led to incomplete data. And because of the incomplete data, we need to make quite a few assumptions to fill in the gaps on many of them. So like timing being a huge one. We use a simultaneous approach, we can use a sequential approach because of that. And timing can have quite an effect, especially when you're looking at growth rates. Growth rates, traffic growth rates, can greatly affect the results of analysis. And if you don't know when a project is going to be constructed, you can't fully incorporate that. Also have to bear in mind that the model used, the CART model, was actually very new at the time. It's still a work in progress at the beginning, and it was developed as the program went on. So without testing a model, there can be errors within the model, and the calculations can be a bit off because of that. A lot of testing has been done on the CART model since then. It turned out there weren't too many things wrong with it. It was a little bit slow in terms of how it was operated, so it's been reorganized since then, and it's also been simplified as well. It's been broken up a little bit more, and that's broken up into the 2. I think it might have been only the 1 model at the time, so that's made it quite a little bit more efficient. But overall, the model didn't perform too badly anyway, but at that time it was considered a risk given the lack of testing. There are also a number of other projects I didn't mention that were included as part of the Bruce Highway Action Plan, and they had been previously evaluated and not using the current methodology, making comparisons completely unrealistic. But that was also included. I think there needs to be a bit of education in terms of consistency of approach to analysis when you're actually putting things into a program. So that was quite a limitation. That was stated quite clearly in the reports, though. in regards to what projects should be compared with each other and how valid those comparisons are. And also as well, you have to bear in mind that given the short time frames, given the lack of data and all of that, the program evaluation was more of a strategic evaluation. It didn't intend to be of any detail. Hence, that's why we had the sensitivity tests of 50% benefits either way and 50% costs either side. It was just to give a broad idea of which projects within the program are going to be most viable and also which ones are going to be most valuable to the program as a whole. Before I wrap up this video, I'd just like to mention some of the projects that are actually being considered in a little bit more detail. And this is going back to 2013. So some of this, again, would have changed, but this was actually done prior to the Bruce Highway Action Plan that we were involved with in the program evaluation. So what I've got here are the benefit cost ratios and the net present values of these projects that are actually being investigated again. As you can see, most of them actually have scored very poorly. As you look at the top, there's that top 6. All of those have benefit cost ratios below 0.5 and actually would be very poor investments. The only projects on this list that sort of stand out as reasonably good, and that's the Mackay Ring Road Stage 1 and the Koroydekara Section C, which actually I believe Koroydekara Section C is actually currently under construction. That was doing as managed motorways, Gateway Motorway. That one's a little bit less cost intensive, but actually has quite a lot of benefits as a non-infrastructure, partly non-infrastructure solution that scored quite well. And I think there's any other projects that scored well, barely getting over. I think it's Mackay Northern Access upgrade, and pretty much everything else is not scoring particularly well. So unfortunately, I think a lot of our advice kind of fell on deaf ears in regards to what projects were actually included. And unfortunately, the Bruce Highway Action Plan was used more, I think it was more of an exercise to show that some work had been considered. And when it actually came down to announcements of actual projects that were going to go ahead, it was just projects that were particularly favoured at the time by the current government. Again, that is a little bit disappointing. I like to think some of our work could have been used to actually better inform what projects were going to go ahead. But this was the list provided at the time. And there's a new list out now. I'm not currently aware of what's on that list. But that, I wouldn't be surprised, would be along similar lines to what we have here. But it would be interesting to see how that progresses and what sort of results we get now that time's moved on. You've got to consider that the scopes of the projects will be a lot more clearly defined. You'd have a lot better data. And also, various factors would have changed as well. Things like growth rates. You'd have different projections than what was going on back in 2013. So getting back to the original presentation that was presented at the conference. So I'd like to conclude on a number of things as part of the program evaluation and how it was applied to the Bruce Highway Action Plan. So first off, we came up with a model. We called it the CART model. This model needed to be flexible to handle the various different types of projects. It also had to be a fairly rapid model as well, and it also had to be able to deal with a lack of information, and it had to deal with that consistently. And I think the model did its job on that side of things as well in terms of how it was incorporated. So then applying it to the Bruce Highway Action Plan, what approach do we use? Do we go ahead with the simultaneous approach, or do we look at the sequential approach? Given the strategic nature of the program at hand, we looked at it in terms of a simultaneous approach, and that was definitely the best way to go about it. The sequential approach would have needed a lot more information and a lot more in regards to project timings and all that. So the key indicators that we looked at are the benefit cost ratio in terms of ranking projects within the program, and for the program as a whole, we looked at the net present value. And for those occasions where options were still out there for some of the projects, we used the incremental benefit cost ratio to determine which would be the best option to go forward as a project to be included in the program, and then competing with the other projects within the program to make up our program. But as a whole, the report at the end of the day went up as a program with all projects included. The advice was provided around which projects should be included and which ones shouldn't be included. And that was done in 2 steps. Well, in 2 approaches, shall I say. There's 2 ways of looking at it. One way of looking at it was to include only those projects that had a benefit cost ratio of greater than 1. another way of looking at it was to include the projects until the value of the program actually dipped below 1, which wouldn't have been too many cut out. But if you look at that in terms of like flooding projects, quite a few of those would have included that if we had it as sub-programs within that program. Another proposed approach, actually in the paper itself, was to look at it in terms of a lower cutoff point for the benefit cost ratio. Maybe not use 1, but maybe use something like 0.8. Given the lack of information, because often if there's a lack of information, we'd adopt a more conservative approach to evaluating the benefits, and that would actually undervalue the benefits in many cases. So we'd be looking at some projects that maybe got a benefit cost ratio of maybe a 0.84 or something. That could eventually get above 1 once we've actually incorporated more information. And in the case, the lack of information often falls on the benefit side. There's more stuff available to incorporate in the capital costs, as a lot of that information is closer to the time of construction. Benefits-wise, that carries out throughout the life of the project. And we used 30-year project lives for most of these projects. So there's a lot of uncertainty around that. So that's actually 3 ways of looking at it and how that was done. The Bruce Highway Action Plan analysis evaluation was a very large analysis. It involved a lot of work and went over a lot of time. And I didn't do all this work by myself. So as part of the presentation at the conference, I actually acknowledged a number of people that played very critical roles in this, and just as critical as my role. I may have actually led the analysis and the evaluation, and I was mostly responsible for the development of the model, but I didn't actually do the analysis of all the projects. So here are the people that actually contributed to this, and contributed a lot of great work. So they are Mark Best, Matthew Singh, Shane Campbell, Alice Alamonte, Michael Oberg, and Robin Murray. So a lot of thanks to those guys and the work that they've done. And some of them are still with Transport on Main Roads now. Some of them have actually moved on. But a lot of good work done by those guys. So yeah, a big thank you to them.
If you like today's video presentation, just click the like button and the subscribe button. And I'll be uploading several more videos in the weeks to come. Again, within the same series, videos relating to the transport conferences, as well as several other videos also relating to economics. If you want to find out more about today's paper, just go to my website at spectrumecons.com and you go to the research paper, just click the link there and you'll get the paper in full. Again, thank you for listening. Goodbye.